On number 171, we actually get to use the part of the fundamental theorem of calculus that I enjoy, which is part 2. So in 171, they ask us to take or to evaluate the definite integral from -2 to 3 of x squared plus 3x minus 5 dx. So I'm actually going to do several of these, so I'll probably just do them back to back. You don't have to keep flipping back and forth here. So on 171, we had the integral from -2 to 3 of x squared plus 3x minus 5 dx. So here, if you're going to do this one, this is the one that's really nice because all you really have to do is take the integral of your function, which in this case is x squared plus 3x minus 5. So remember to take the integral of x squared, you add 1 to 2, divide by the exponent that you have, and so on and so forth. So I'm going to go through and do that. And then you just evaluate it from 3 to -2 by subtracting those two things out. And that's it. So here we go. If I take the integral of x squared, I'm going to get x cubed over 3. And if I take the integral of 3x, I'm going to get plus 3. That x is now a square because I bump it up 1, divide by 2, and then minus 5x. Now I'm going to evaluate that. That's what that bar is for, from 3 to -2. And so now that I've, to this point, all I'm going to do is take the 3, plug it into what I took the integral of, or excuse me, plug it into the actual integral, and then subtract from it -2 plugged into that integral. So I'm going to take 3 cubed over 3 plus 3 times 3 squared over 2 minus 5 times 3. I'm going to get that answer, whatever that ends up being. And I'm going to subtract from it what happens when I plug in -2. So I'm going to have -2 cubed over 3 plus 3 -2 squared over 2 minus 5 times -2. So what do we end up here? 3 cubed is 27, divided by 3 is 9. We've got 9 plus 3 squared is 9 times 3 is 27 over 2 minus 15 minus, what we got? -2 cubed is -8/3. -2 squared is 4 times 3 is 12, divided by 2 is 6, and then plus 10. So what, I'm out of room here. So what I recommend you do on your calculator is put in 9 plus 27 halves minus 15, get that answer. And then do -8/3 plus 6 plus 10, get that answer. Subtract those two numbers from each other. And when you do, you should end up with -35/6. Look how pretty that is. I mean, after we have done those rectangles where we've done 100 rectangles and 50 and 10 and 4, that's just too many rectangles. This is so much prettier. Let's do another one of these. So I'm going to do number 177. So I've got the integral from 1/4 to 4 of x squared minus 1 over x squared. You know I'm going to fix that. So I don't like the 1 over x squared because it's hard to figure out like what you're actually dealing with. So I'm going to use my exponential rules to rewrite it just like I did with derivatives. So I've got 1/4 to 4 of x squared minus x to the -2 dx. Okay, so using part 2 of the fundamental theorem of calculus, I am going to go through and I'm going to say, okay, the integral of x squared, remember, is going to be x cubed, to add 1 to the exponent, divide it by the exponent, minus, add 1 to your exponent. So in this case, my exponent is going to be -1. So we got x to the -1 divided by -1. That's going to make a sign change for me. So this is really going to be plus a positive. The one on the bottom doesn't do anything. And then I'm going to evaluate that from 1/4 to 4. So if we plug in what we know now, remember you plug in the upper boundary, which is the 4, subtract from it the lower boundary plugged into your what you integrated here. So I'm going to have 4 cubed over 3 plus the x to the negative 1. Remember, we can actually write that to be plus 1 over x. Means the same thing. So I could do plus 1 over 4. And then I'm going to subtract from that. Let's plug a 4th in. So we're going to have a 4th cubed over 3 plus 1 over 1/4. Whatever that ends up being. Here, guys, if we work this out, we're going to have 64 thirds plus a 4th minus, if you do 1/4 cubed, you get 1 over 64, and then you really have to put the 4 on the bottom of the fraction, so you get 64 times 3. So here I'm going to have 1 over 192 if you work all that out. And then this 1 divided by 1/4 is the same thing as multiplication by the reciprocal, so it's actually plus 4. So if you work the 64 thirds plus 1/4 out, get an answer. The 1 over 192 plus 4, get an answer, and subtract those two answers out because I am now out of room. You will get 1125 over 64. And again, I love this method. It's so much nicer than what we were doing. That's why I cheated and show you how to do that in the last video of the last section. All right, let's do another one. I'm going to look at number 183. So 183 says we've got from 0 to pi over 2 of sine theta, d theta. Check something. Okay. So just like we did last time, I'm going to take the integral of sine. The integral of sine, remember, is going to be negative cosine of theta. To get negative cosine of theta, I'm going to evaluate that from pi over 2, or excuse me, from 0 to pi over 2. I always end up saying that backwards. I apologize. But we are going to plug the pi over 2 in first. So I'm going to do the negative cosine of pi over 2. And it's going to be minus negative cosine. So the minus comes from the fundamental theorem of calculus of 0. By the way, we're going to have the cosine of pi over 2 is 0. So negative cosine of 0 is still going to be 0. So I'm going to have 0 minus a negative. Let's see. Cosine of 0 is going to be 1. We'll make it negative because of this negative right there. 0 plus 1 is 1. Oh, these are so nice. I'm so happy about these. Let's do another one. Let's do the integral. This is going to be number 191. Have our directions changed yet? I don't think so. Oh, yeah, the directions do change on number 191 to say, oh, use the evaluation theorem to express the integral as a function, big F of x. Guys, what does that mean? You're using part 2 of the fundamental theorem of calculus. It's called the evaluation theorem. So same thing. So we are doing the integral from 1 to x of e of t dt. I love doing derivatives and integrals with e because the integral of e of t, just like the derivative of e of t, is e of t, evaluated from 1 to x. Now, something I want you to understand here is, please notice, this is not both numerical boundaries, right? X is actually a variable. I don't know what x is. So in this particular case, we're not going to get a numerical solution. So I don't just get one number as my final answer. I am going to have to keep my e's in here because I do have that x. So here, I'm going to do it the same way, though. I'm going to do e of x. So x is replacing the place of t minus e to the 1. And yeah, that's actually my answer. I don't know what e to the x is. E to the 1's e. So it does clean up like that, but I can't do anything else with it because that's a variable as one of your boundaries. All right, cool. Let's do another one. Actually, you know what? I'm going to save this one because I want to pull up the directions. So I will do it on the next video. See you then.